I'm here with Brian Lucas from Optimizely. This talk is going to be how to win in software development with tighter feedback loops. I'm Jay Dave, your host. We've had a great crowd all day. It's been really good to see these questions coming in. Quick reminder again, keep adding those questions in the Q&A panel. A bit about me, I lead the product marketing team for BrowserStack's test automation products. As a product marketer, I spend a lot of my time, studying testing and talking to customers, aka some of you. One of the best learning experiences for a product marketer is really to sit down and talk to your customers. And last year, I had the chance to do that with Brian Lucas, who's our next speaker. And I really got the chance to sort of talk about how they do things that optimize, the best practices that they've built over the years. And I'm now excited for him to share what's been cooking under the hood. Brian Lucas is a senior staff engineer at Optimizely. He's responsible for the build, test, and release process. Formerly, he was CTO at Credible and Hoopla, and the lead architect at Slingbox. In his talk, like I mentioned, he'll be talking about how you can use tight feedback loops to improve your velocity using fast, reliable, and modular mechanisms. Brian, you can take it from here.
Cool. So I'm going to jump in, and this is my hope is that this is relevant for everyone, both an engineer on the DevOps team and on the QA group. I'm going to stop sharing my video because I think when I turn on screen sharing, it'll allow me to expand it a little bit. But very nice to meet all of you, and I look forward to chatting after this to take some questions. Cool. Well, let me get started here. So my talk is called Building Effective Feedback Loops in a High Throughput Build and Test Environment. This is lessons learned over a number of years at Optimizely and other places. We've taken a lot of lessons from Google, where a number of our engineers have come from, Facebook, and so on. So without further ado, I'm Brian Lucas. As I mentioned, I'm at Optimizely. In the past, I was responsible for building out a group focused on these build processes that I'm going to talk to you today. Now I focus a bit on the billing platform within Optimizely. Prior to that, I was at Credible, where I was a CTO. They did quite well. And before that, I was at Slingbox. You may know that now as Sling TV. I was lead architect there. So without further ado, what exactly is a feedback loop? Why should you care? Quite simply, it's a process in which the outputs of a system are circled back and used as inputs. So what are some examples? Well, you might see something like placing an order on Amazon. And I actually had a failed feedback loop. I was hoping that I could order a microphone today, so I could have one of those radio style microphones through this e-commerce feedback loop. And that actually did not materialize, but luckily my trusty AirPods are here. Social media, we have those things in our hand where we want as many likes, and we're constantly in this cycle of posting information and coming back to us. Pavlovian conditioning, a dog with a whistle starts to salivate. He thinks there's food coming. Those are all, I suppose, examples of what we're used to when we talk about that. But how does it apply in software development across the entire life cycle? Well, this is what we're going to focus on today. First step is deciding what to track. I want to tell you a little bit about successful software companies. So there's a number of traits in successful software companies: high velocity, high levels of quality, and high developers. Clearly highly productive developers, I mean. So unfortunately, as software complexity grows, so do the costs to develop it. So a lot of these things materialize as safeguards, slowdowns, and risks. And a number of people on this group can probably identify how those things start to build up. On average, around 50% of a developer time is spent fixing bugs, depending on the maturity of the organization. So clearly, things aren't always a walk in the park. You've got a lot of internal risks, a lot of customer risks or external risks. When your software application expands, clearly there's so much surface area that you can't possibly catch every possible permutation of that use case. So what do we do about this? Well, faster feedback loops help us address this paradox. You may have heard something about small change sets, rapid iteration, rapid releasing. Well, there's a lot of truth to that. So you gain certain benefits from that, quicker insight, you reduce your risk because there's much lower surface area, and you have less overhead to manage cognitively. So just real briefly, this is an example, and you'll begin to identify sort of where your organization fits in to this. For example, when you're in early stage, the y-axis on the left is velocity. The early stage companies are very quick and easily able to iterate and deploy with high velocity. So as an example, maybe a Y Combinator startup. High velocity, deploy directly to production. A lot of autonomy. Let's say you're a little bit further along, you're an established startup. Your velocity is probably going to drop down. You introduce new environments, you've got new processes to go through. You're not, every new piece of code may not necessarily be something directly to production. You might be doing back office processes. You might be doing other things that improve an existing process or refactoring. But your build and test cycles are reasonably fast as far as your velocity goes. When you start moving into enterprise, you start to see a little bit more slowdown here. So let's talk about maybe you start to get from one extreme to the next, maybe quarterly releases. You have a large team dedicated just for front-end QA or just for back-end or just for visual regression. You do have more confidence, but things take a lot more time to do. Finally, mission critical, where you might have an annual release, NASA, every line of code statically checked. So what does this all mean? Well, there's clearly a number of trade-offs here. I'm not going to go into each one of those, but clearly there's a couple things to think about, and we want to focus on improving this. So when we start to dig into this, a couple questions we want to ask ourselves. Where does your organization line up? Well, most groups will probably line up maybe somewhere around the middle, depending on the size of your team. What steps can you take or can groups take to help improve their velocity? Well, that's actually what we're talking about today with feedback loops. And finally, where do the highest performing companies excel? Well, thankfully, there's actually some direct answers and anecdotes around that. If anyone knows the DORA State of DevOps study, really profound, really useful pieces of information. A couple quick takeaways from that. They've actually broken down into different strata between elite down to the lowest performing groups. And you can see here how those groups are actually set up. But I'm just going to focus on the elite performers here. So when you think about deployment frequency, how often you get out to production, you're actually thinking about what that means in terms of multiple releases a day. How long does it take for you to anticipate and get code out to customers? How long does it take to fix something, your MTTR? And what does that change failure rate look like? Are you just throwing things out to the wind, or are you methodically improving and taking steps to ensure a high degree of quality? So elite performers find ways to build these tight feedback loops. Did you know that based on the highest to lowest performing ratios on this study, those elite performers were releasing code 208 times more frequently than the lowest performers, 106 times faster to get code from commit to deployment or into production, based on one extreme to the other. It's all fascinating. And the way they do that is by really focusing on getting this information out to their engineers, as well as all the other stakeholders. So I want to focus a little bit now on what some of these things look like. We're going to talk about tracking metrics within your build and test and release processes. So think about it at a high level where without these meaningful metrics, you're tasked with improving a process, but you're chasing windmills, the Don Quixote fabled approach of looking out in the distance, trying to find something, but not actually having a meaningful way to make progress and tackle it. Same goes with visualization tools. You're actually missing out on it. People will think about those graphs and charts and say, oh, that looks easy. I don't really need those. You're missing out on very simple, easily discernible visual cues without that. So what are some examples of things we might be interested in tracking? There's a lot, and clearly everyone can think of probably dozens, if not hundreds of metrics, but we'll talk about a few. Durations, like build duration. What are my success or failure averages? If I run the same process 10 times on a known stable piece of code, how often does it succeed and how often does it fail? That also might be similar to the stability. What is a flaky test and how often do those tests flake out? Very simply put, a flaky test is something that's non-deterministic in its nature. A production commit per day, or number of production commits per day or per week or per month. As well as finally, maybe the productivity of your developer. What's the time from first commit to the time it makes it into production? Why should you concern yourself, or why should you bother tracking this information? Well, this is real money here that adds up. So let me give you a couple examples. Let's talk about the first one, lost productivity from unstable builds. We'll look at number of minutes, for example. Very simple equation that you can do on your own. Total commits times the average build time times the stability ratio. I'll give you some examples here. 300 commits made by your development team in a week. It takes 30 minutes for that build to go cycle through, and 90% reliability on that entire process. So if you're looking at a hypothetical example like this, you're actually missing out on 900 minutes per week. Engineers are expensive, same with every other person on the team that's waiting for that feedback. Let's look at the intrinsic commit build cycle. Here's another interesting one here. Build runtime, maybe 25 minutes, times the cost per machine hour on EC2 or Azure or Google, what have you, times or plus the cost per your development hour. Let's say it takes 25 minutes to build. Let's say your system queues for 5 minutes, $1 per machine hour, $100 for your developer hour, and that might be generous or it might be low. I mean, take that as an example just for this equation. But if you assume these constraints, we're looking at around $50 for one build. You clearly want to optimize and you want to make improvements on that. That's a very expensive feedback loop. So one of the things that we did back in 2016 was start focusing on how to quantify some of this abstract information. We created a pain index. We called it, I think, originally a developer pain index. It's probably more appropriate to call it build pain index. And what is this and why should you care? Well, a developer pain or a build pain index is pretty simply the time it takes to receive feedback on your change. It's quantified in a number, and you want to see it decrease over time. So think of it as the median build time, to exclude outliers or things that might take 50,000 minutes or some unbounded amount, over the build success ratio. You start to figure out how painful it is for a developer to receive that feedback loop information that they're waiting for so that they can make a change or fix a process and move on to the next component that they're tasked with doing. As an example here, we've got 90% median success rate, 30 minutes for build time. I'm looking at a build pain index of 33.33. If it takes me 15 minutes to build my entire test suite and build process and deploy it, but I'm looking at a 65% build success rate, I've got about 23 minutes or 23 on my BPI. I want to see those things move down. So why should I track this? Well, because developers hate unstable builds, think of it as a corollary to developer happiness. So reducing instability for developers as well as everyone else makes gives you as a developer, as an engineering leader, a much tighter loop and control over iterating through quickly, makes developers happier, allows them to level up and move code quicker through the process, and it lets you get code out much quicker as well. Once you can calculate your BPI, you can actually justify and take some of these findings internally or to product or any other stakeholders and tell them we need to improve this process. Look how much it's costing us. So when we put all these metrics together, here's an example of what we've built out. We've built out multiple visualization tools, but what it looks like visualized for developers, something as follows here, where this is maybe an informational grid of how each one of our test suites or build processes are doing. We've got a similar metric on how well performing our development builds over an integration cycle look. And then we're tracking our DPI over time. And if that goes up or down, we know that we've made some meaningful changes or there's been some regressions over the past week. So this allows us to drive improvement over time. This is an exec level dashboard. What this lets us view is if I'm a CTO or a stakeholder, I'm an engineering manager, an engineering leader, I'm able to actually take some of these metrics and drill down on how well and how tightly controlled this process is and how we can take steps to improve this while increasing the productivity of everyone across the team and getting code out faster. So here, what I've actually been able to drill down into is from that equation I shared earlier, I could tell from this week, I had 102 builds that were broken, and this cost my team or our team 72 hours of lost productivity. That's expensive. So moving along, measurement and visualization are key here. These metrics all need to be collected somehow. That process isn't simple, but JUnit is a great starting point. Uploading that, parsing those are a really good starting point on how to create that feedback loop. I want to go into that next part here. So we've talked about deciding what to track. Let's give some examples of what you might do and how you might automate that. So here's what our build deployment release strategy looks like at Optimizely. This is probably fairly similar to most of your build release strategies, depending on where you are, but starts with continuous integration down to delivery, down to deployment, and that's a manual step at that final place. Everyone might have some aspects, all of these aspects, none of these aspects, but the key part here is that most, if not all of it, down to where it can be is automated. So a well thought out process in this feedback loop looks like something similar to this, where you've got a build, test, release, gets out to customers. You take that information back, you plan, goes back to the developers, and that loop continues to move forward. So when you automate everything, you're actually taking some great steps, which look like this, where but not only are you building out the initial frameworks to do this, but you're also helping your engineers move through this a lot quicker versus babysitting one step at a time. This gives you better feedback where you know that you've got reproducible deterministic processes, much fewer surprises on the way, less snowflake builds or very unique, hard to create components or artifacts within your build process. And it gives you a much higher degree of confidence in your deployment. So what are some examples of bad or maybe not bad, maybe low efficiency feedback loops? Well, here's one that we can all identify with. Let's talk about standard process here. This is what a software development lifecycle might look like. Design it, build it, deploy it, send it to QA, fix it, and then release it. This is around 2 weeks of time just for one change set. That's a lot of time to get code out to customers and get feedback on it. So resembles what I think some people have already shared here. Mr. Ice Cream Cone, very top heavy on the manual process. So this is what we all may or may not have experienced at some point, and some of you may still have this, where developers are here throwing chunks of code over across the fence to our friends at the QA team. They don't look very happy about that. And while we're initially inclined towards this model, you can quickly see that this is maybe psychologically why we're inclined to this. The engineering effort is very low when you build out or when you assume a top-heavy approach here. The engineering effort to build out unit tests and every other aspect is high. But that corollary is also manifested here as well. The validation effort is also much higher when you sacrifice the developer effort for the validation effort. How can organizations like yours improve or create more efficient feedback loops? Well, one example might be a very simplistic code coverage tool. Now, these, I have mixed feelings about the efficacy on some of these. Sometimes they're reliable, sometimes they're wildly inaccurate from one commit to the next. However, it's a very simple starting point to ensure that you have a reasonably suitable high degree of code coverage. And that looks like something as follows, where you make a code commit, it comments on it, you have that moving forward. Talk about one of the most impactful ones that you as an organization can have for developers, for QA, for anyone for that matter. A GitHub integration and a Slack bot. So very simple to visualize this. Create a pull request, you tap in through some mechanism of your choice to a GitHub webhook, and voila, now all of a sudden you've got a message that starts that process, kicks off the release, and your build pipeline walks through start to finish, what that starting point down to the end looks like here. So in this example, I've unblocked my developer from having to sit around and wait for that process to complete. They can now context switch because they know that they'll receive a notification when that process is complete. And that's a very efficient feedback loop, which allows or empowers your developers to go off and perform other things while they're waiting. This is an extension to that, perhaps. What about feedback loops for your release notes? So consider the same process, open a pull request, tag a JIRA or tag something else in that, write up your summary and your description. This can actually be turned into release notes or a change log, and you've got some information that you can disseminate both internally or externally. And one of the great ways that we've had some success in scaling our QA team is by taking this very approach, but actually tasking our engineers as being part of that extension to QA. So the engineers who wrote the code, wrote the unit tests, know this process inside and out. They own and are accountable for the quality of that process. In this situation, when we've released or when we're getting ready to release code out to customers, we'll ask engineers to validate this process or validate their code before it goes live. And we've scaled without putting 200, 20, 10, some arbitrary number of commits onto a separate team. We're actually asking the engineers to own this process. So what else can one do to improve and scale build and test processes? Well, prioritizing your process and frameworks, not necessarily just to test or build, is important. You want to have common frameworks, common tooling, avoid one-off approaches. Also, keeping your test signal to noise ratio high is also very important here. The tests over time will become brittle. We all know this. They're prone, especially in the end-to-end tests, to become problematic. All of those external actors, your CDN, your third-party JavaScript integration on your website, if you're doing a true end-to-end test, any of those things can either experience latency or delays. You want to mitigate, find owners on those tests. You can use that, do it pretty simply with GitHub code owners. Here's an example of how Facebook does it. They actually implemented a quarantine process with a system called Green Warden and Test Warden. And it's very simply a feedback loop that takes or evaluates the effectiveness of a test and quarantines it and notifies a developer that it needs to be fixed without breaking or causing problems for other developers down the road. You want to keep those, as I mentioned, you want to keep the test signal to noise ratio high. We've created a consumption process that bubbles up poorly performing tests over a certain time interval, where if over the last 24 hours, a certain group of tests have started performing poorly, that information gets surfaced quickly and we can choose to take steps to mitigate or improve that. So going back to this, when you can invert that ice cream cone, make it more of a test pyramid, you actually turn this into a much simpler validation effort, and things become a lot quicker as part of this feedback loop. You share the love with all of your team, including the dev, product managers, and the QA team. So finally, I've covered both deciding what to track and automating your feedback loops. Now let's talk about how you might be able to take some additional examples of decreasing feedback time and feedback loop time through some experimentation. What we do at Optimizely is we have a number of products, but our core product here is experimentation. One of the corollaries to that is feature flag. So by itself, a feature flag is a very simple on-off toggle switch. Allows you to put a potentially risky piece of code behind a simple on-off flag and selectively decide when to enable that. A feature rollout is an extension to that. Allows you to take, for instance, an Android phone or an iPhone or a web desktop and decide when and how to turn those features on. And if you want to enable something or disable something, very simple and straightforward to do. But you can also do this for your engineering processes. So when this looks like building something, the traditional process might resemble something where you're designing it, building it, launching it, praying for the best. Clearly, that's not always the best way to go. Why not introduce a deployment flag where now all of a sudden you're able to iterate and experiment your way through, get a little bit more confidence in that process? How would we implement something like this? Well, one simple way, either on a back-end process or a front-end process, is through traffic splitting and feature rollouts. So if you're worried that you may have not caught something or you may not have had enough extensive bake time for a very large audience, put it behind a process like this. One example might be, Optimizely is a company that processes around 500 billion to 1 trillion events per month, depending on the time of year and depending on how busy some of our customers are. Is one CDN provider better than another? That's clearly a very important aspect to us. We can run those in a bake-off transparently and collect data to help determine the equivalence or superiority of one provider. So in this case, you might create two variations, vendor A and B, make some measurements here, and then figure out whether or not your results made sense or were beneficial based on your baseline change. You might be able to do the same thing internally on de-risking a crucial new product launch or a crucial new change to a back-end service. As I mentioned, where we have around 500 billion events per month, we collect and aggregate and surface or show that information to our customers. We have to do it in a highly performant way. One example was that this was starting to take a long time. If we decoupled some of the paths for that counting logic and actually took it down a more efficient route, would we be able to see some meaningful improvement? One way that you can answer that is deciding whether or not you are willing to wait several months to try your variation or your baseline, and then several months to try the alternative. That's not ideal. You can get much quicker feedback by implementing some kind of feature rollout here. And here's one example where we had two paths where an API query that surfaces data to customers might go. It might take path A, which is the baseline, or path B, which is our new shiny counting service. So we started collecting this information and surfacing this or storing it over a period of time. And one of the ways that we were going to decide if we were successful was to determine if the latency or the time to respond had actually improved. So here, clearly there was a marked external improvement there. What about on the latency? Well, there was actually quite a bit of latency reduction here. And this actually gave us enough confidence that we were able to proceed in a fairly quick way versus waiting months on end. So we shortened that feedback loop. When we had a little bit of additional time, we implemented a monitoring system within Datadog to observe these failures or performance, make sure that there wasn't a skewed ratio of 200 to 500 errors and things of that sort. So one final kind of quote here: it doesn't matter how beautiful your theory is, it doesn't matter how smart you are, if it doesn't agree with your experiments, it's wrong. Richard Feynman, Nobel laureate, worked on a number of critical aspects in the 20th century. So finally, how might Google short circuit some of their feedback loops? Some real world examples here. They've built out, for instance, a search page, let's say IBM, which coincidentally was right before us here. Let's say IBM had an experiment where they wanted to know if people were searching or clicking on IBM.com or the wiki link. Well, hypothesis A or B. So they actually ran a couple simple experiments here. They took that information, started iterating through, improving the results as well. These two examples are very similar, but there's actually the quintessential classic pixel pushing optimizations in play here. A and B look almost identical with one exception. That plus sign is larger. And Google ran around 9,800 search experiments in 2016 and around 1,600 releases based on the findings from that. So today, you might see something like this, where after all of those results and all of those feedback loops, you've actually seen this manifest in a much more robust search page when you type IBM than something else. Final thoughts. First off, it's important to decide what to track here. So there's a lot of items that I've put out there about metrics. Determine what's important. It's very easy to shoot for the moon, but you don't want to try to capture all of that at once. Better to iterate than to get it perfect initially. Now, after that, measurement and visualization, as I described, are also really important to do here. You want to capture your meaningful metrics over time. You want those visualized so you don't miss out on those visual cues. Deciding how to quantify your improvement and progress over time is also really critical here. A build pain index allows you to justify investment in process improvement and turn your developers into 10x engineers with reliable build and test processes when you're collecting and quantifying your progress over time. Now, it doesn't have to be any one of these items, so long as you're tracking that information over a period of time and you can decide when and how to allocate or justify investment in improving that process. Finally, you can decrease some of your feedback loop time with experimentation. You want to invest in testable hypotheses that have well-defined variables. You also want to build trust in the data so that you can actually ensure you're working off of reliable data and that you trust those numbers when they come back to you. So thank you. I'm going to turn this, I guess, now on to some Q&A, and happy to chat with everyone based on any questions.
Awesome, Ryan. Thanks for sort of giving us a closer look at what Optimizely is doing, and some of the developments around the build pain index, and how you sort of use feedback loops, to drive that down. We have a few questions. I'm going to start sending it over to you. So we have some around. I think the audience appreciated some of the reports that you had in your slide. What tools or products do you use to build some of these reports?
So there's a number of options for you. I think right now we're visualizing some of our information with Honeycomb, but there's a number of other tools that you have at your disposal. A number of the tools that we still use today are things like Chart.io, which provide a number of simple SQL-driven visualization tools. And that's a really good starting point to expand or at least test out or try those things out. So I'd start or suggest perhaps something like Chart.io or another BI type of tool that you can use SQL with.
Got it. We have another question, and this is around when these reports are being presented to a larger team, squad, or company. Is it better to sort of have more, data-based, text-based dashboards, or more visualization based in your experience?
So there's both, and they both serve different points. There's no reason why a visual dashboard is more beneficial than a text dashboard, other than the eureka moments or the high level at a glance information that you can get versus doing some of that drill down. So I work a lot with things like notebooks within like Spark and data processing. Some of that information is better explained or better used within like a text-based format. Some of that information, however, is more meaningful and easier to communicate to stakeholders or exec level when you have visual tools. So I'd say decide who your audience is, decide what those tools that need to be surfaced and what those insights are, and then go from there to decide what works best for you.
Awesome. We have another question. How did you build your dashboard?
I think I mentioned that earlier. We use some off-the-shelf components. Some of the ones, I'm assuming it's referring to some of the slides that I've shown some examples on. In this case, several of the dashboards that we built were done with Chart.io.
Got it. Now we have a question asking for your input. So we have a huge set of tests split to run across 3 stages in the CI pipeline. At the last stage, we consider that build to be shippable to customers, but there's a lot of time and resources that go into that. Is there any suggestion on how we can bring down the execution time?
Absolutely. So the greatest aspect that you have at your disposal when you're trying to figure out how to deal with these scenarios is exploring parallel processes. Most of the tests should be standalone, and hopefully your unit tests, your end-to-end tests, or any other process for that matter is largely decoupled and it's not necessarily sequential. When those processes are not sequential or have no bearing on a preceding process that needs to occur, it's very straightforward and very simple to turn that into much more of a horizontal approach versus a sequential or a linear approach. When you can move those into horizontally scalable processes, and let's say I have 1,000 unit tests. If there's a way for me to distribute those 1,000 unit tests into groups of 10 or 20 or 50 or 100, I can actually abstractly run those in a fraction of the time. And the process then becomes, how do you collect those? Most of these frameworks have various formats for doing that, but you have to collect the results. And that's where you need to spend a lot of time answering that based on the tool of your choice. But the short answer on how you can improve that process is making investments and finding out ways to increase parallelism and horizontal scaling.
Awesome. We have another question around the test quarantine approach. I think they want a double click. Can you expand on that process?
Let me see. So I think if the question is, can you explain what a test quarantine is or how it works? The most important aspect for exploring how a test quarantine works is to decide what that baseline success ratio is. And ideally, it should always be 100% for an individual test in a stable branch or a stable mainline piece of code. If that exhibits some kind of non-determinism, and again, that's just defined as really a process that does not perform identically from one run to the next, all other circumstances being equal, then you exhibit some type of non-deterministic flaky behavior. In order to track that, you need to be collecting a series of test runs and a series of previous job executions and decide at what threshold that makes sense to take that out of rotation. So this might be a future talk or a future point of discussion. There's a lot that would go into a process like that. But at its core, the way we've done that is we've set an arbitrary threshold of acceptable failure rate. If the test history over time falls below that, then we'll mark it as a quarantined test or a disabled test and take it out of execution. Or if nothing else, we may run it, but we will not allow it to fail the build if it's been marked as a potentially flaky or unreliable test. So I hope that gives a really high level part. The most important part that I can tell you about each of this is collecting those individual metrics for each one of those tests over a period of time, and then deciding based on a threshold whether or not there's some meaningful cutoff or threshold that you feel comfortable as an engineering group turning that test off or disabling it so it doesn't impede or block the progress of other developers.
Awesome. Thanks for answering that, Brian. We have a question around the build pain index. How did you come up with it? And if someone wants to, I think we have another question. If someone wants to get started with that, how should they?
We came up with a build pain index a long while back when we were searching for a meaningful way to track our progress and improvement over time, and think of it as maybe an OKR improvement. Or if many groups know about OKRs, your objective and key results, you're looking for a measurable, quantifiable way to decide if something's improved from a starting point to an ending point or over some determined period of time, and figure out if you're taking steps to improve or if things are regressing. So in order to provide that in a quantitative sense, we looked at all of the information that we had available. We looked at what was the most meaningful for developers and engineers. And the most important thing in engineering is shipping code and your velocity. At least that's of my opinion. There's maybe other commentary that talks about, having really high quality or deciding what the product market fit is and how engineers adapt to that. This was one of the easiest or most straightforward ways to track what a core crucial metric of an engineering group was. And that was deciding how painful and how long it took we or ourselves to get code out, and then decide if we were taking steps to improve or decrease the process or the time it took for engineers, developers to get feedback on their changes. Because in order, hypothetically, let's say it might take 1 week of time to open a pull request, make the necessary changes, get feedback, and actually commit into your mainline branch, you're probably doing anywhere between 2 to 10 commits after you get your feedback on your pull request and after you validate that it's doing what you intended it to be. So that's a lot of time in order to get changes. And in the worst case, developers are blocked from doing anything else. Context switching is expensive, it's mentally taxing. When you move back into being able to empower those people to get their job done faster, this actually turns out to be one of the best ways you can level up your productivity of your team.
Awesome. I believe we have covered the questions.
Very good. Well, I was
question?
really happy to present to everyone. And as I think Jay mentioned earlier, there's probably going to be some recordings shared across the group. Happy to engage more for questions, but I hope everyone across the spectrum found it useful. I tried to make it applicable to groups of all disciplines.
Thanks, Brian. Yeah, I'm sure of it. Thanks for sort of coming on board, and appreciate you sharing sort of how you're solving some of the problems facing the entire industry. So thanks again. It was awesome having you on board as a speaker.